Hello students, now in class 11th I will tell you about the numerical questions. Numerical problems. Now I would like to tell you some points about this simple pendulum. If length of simple pendulum changes by plus minus x%. Its time period will change by x by 2%. Plus minus, here the plus sign is taken for the increase in length and minus sign is taken for the decrease in length. So if the length is increased by x%, then the time period will increase by x by 2%. If length is decreased by x%, then the time period will decrease by x by 2%. So if we take L, change in length, and here the change in time period, if suppose this length increases by x%, this increases like this, then the time period will also increase by x by 2%. If the length decreases by x%, this goes like this, then the time period will also decrease by x by 2%. So the up sign is for increase and down sign is for the decrease of the this length. If G changes by x%, plus minus x%, the time period of pendulum will change by minus plus x by 2%. What does it mean? That if suppose G increases by x%, then the time period will decrease. Minus sign is for decrease by x by 2%. If G decreases by x%, then time period will increase. Plus is for increase, x by 2%. So here I can show that change in G and here is change in time period. Change in time period. Suppose G, this is x%, this is increased, then the time period will x by 2%, this will decrease. If this is x% decreases, then this will increase by x%. So this is just opposite to this change in value of g. So again the plus sign is for increasing and down sign is for decreasing. Now there is one more. Let t1 equal to time period of pendulum under the force F1 and t2 equal to time period of pendulum under the force F2. And let's suppose a combined force time period for combined force then this t is equal to t1 t2 upon the square root of t1 square plus t2 square. This is the formula. So you may have the questions from numerical parts like this. Time period of oscillating bar magnet. Now this t is equal to 2 pi square root of I upon mb. This is the formula. And time period of liquid oscillating in U2. This is like this, that suppose we are having this U2 if suppose this liquid is filled in it, this is suppose the height h, and this oscillates so that its time period t equal to 2 pi square root of h upon g. This is given by this one. So these are some factors which I have to tell you when there is a change or there is some force F1 and F2 and they are having the time period T1 T2, then you find the time period of the when the combined force acts on the pendulum. So this is for bar magnet, this is for U2. Now I take the numerical part of this one. Now first is numerical is number 1, a particle executing SHM have velocities B1 and B2 at distance x1 and x2 respectively, from mean position. Then you have to prove that now this t is equal to 2 pi square root of your x2 square minus x1 square upon b1 square minus b2 square. This you have to prove. Now we know that this velocity v equal to omega square root of a square minus x square. This is the relation that we know. For x equal to x1, b1 equal to omega square root of a square minus x1 square. So this we can write b1 square equal to a square omega square minus omega square x1. Just to square both sides. This is your number 1. Then for x equal to x2, b2 equal to omega square root of a square minus x2 square. And now you can have this b2 square equal to a square omega square minus x2 square omega square. This is now number 2. Now from both these equations we have to eliminate a square minus omega square. So this subtracting equation 2 from 1. 2 from 1. So 1 this will be your b1 square minus b2 square equal to b1. So this is your x2 square omega square minus x1 square omega square. So this is your x2 square minus x1 square into omega square. This is b1 square minus b2 square. So omega equal to square root, we can have this b1 square minus b2 square upon x2 square minus x1 square, and omega is equal to 2 pi upon t. This is square root b1 square minus b2 square upon x2 square minus x1 square. So this is like to this one, and now we have to find the t. Therefore t equal to 2 pi square root of, this is your x2 square minus x1 square upon b1 square minus b2 square. This is the required relation. This is the answer. And now the second question is the time period of a particle executing SHM is 2 seconds. 2 seconds. At t equal to 0, displacement is equal to 0. At what time its displacement is half? Now question is, at what time its displacement is half of amplitude. Half of amplitude. So now how to find the solution of this one is, you are given that t is equal to 2 seconds. This is given to you, and now displacement equation is y equal to a sin omega t, because at t equal to 0 displacement is 0, so we have to take this equation. There will be no phase difference, that we have not to consider. Omega equal to 2 pi upon t. So this is your 2 pi. T is equal to 2 seconds. Here is given 2 seconds. So this omega is equal to pi. So now you can have this in place of y. You are given to displacement half of the amplitude. Now at y equal to a by 2. What will you have? This a by 2 equal to a sin omega t. Now then we can have this, therefore sin omega t equal to 1 by 2, and this 1 by 2 is in a 30-degree angle, so this omega t is equal to pi upon 6, 30 degree. Omega equal to 2 pi upon t into t equal to pi upon 6. Now this pi and pi will cancel, and this is now 2 upon 2 into t equal to 1 by 6. So this 2 and 2 cancel. Therefore, t equal to 1 by 6 second. This is the answer. So in 1 by 6 second, the time period, the displacement will be half of the amplitude. And now third question. The acceleration of a particle, the acceleration of a particle executing SHM is your 12 centimeter per second square at distance 3 centimeter from mean position. At distance 3 centimeter from mean position. Calculate its time period. Now you have to calculate its time period. Now when we see this question, then we are having the acceleration. So we have to take the relation of acceleration. Now here this is given that acceleration equal to 12 centimeter per second square, and we know that this acceleration is equal to omega square y is equal to 12. Now time period you have to find. So omega equal to 12 upon y, the square root of this one. So this is equal to 12 and y is given to you. This is now 3 centimeter there. This is now 3. Square root of this one. This is your 2 pi upon t. So this is 2 pi upon t is equal to, this will cancel by 4 times. So this is now 2. 2 and 2 will cancel. Therefore t equal to pi or t equal to 3.14 second. This is the answer. So either you write down pi or you write down 3.14. That will be the answer of this question. And now fourth question. What is the time period of harmonic oscillator of length 9.8 upon pi square. This is given. So now you can solve this equation, this question, just by having the time period. Solution: t equal to 2 pi square root of L upon G. Now here L is equal to 9.8 upon pi square. This is given to you. So this is your 2 pi square root of L, 9.8 upon pi square into the value of G. You also take this 9.8, this will cancel. So this is your 2 pi upon pi. Which is now pi square. So this term will cancel. So this is now your 2. T equal to 2 seconds. This is the answer. Now I am telling you one more question. Now question 5. Fifth. The time period and effective length of the simple pendulum are 4 seconds and 4 meters respectively. The time period and effective length of simple pendulum are your 4 seconds and 4 meters respectively. What should be its length? Its length so that it completes. It completes 15 oscillations. 15 oscillations in 30 seconds. In 30 seconds. This is the question. Now you will have its solution. Now time period T equal to 2 pi square root of L upon G. This we know. Now we are given the time period. Now this T1 equal to 2 pi square root of L upon G, and for T2 equal to 2 pi square root of L2 upon G. So now if you find that this T2 upon T1 equal to square root of L2 upon L1. Now you have to find the length. So this is T2 square upon T1 square equal to L2 upon L1. Or this will give you the L2 equal to L1 into T2 square upon T1 square. Now you are given L1 equal to 4 meter and T1 equal to 4 second, and here this you find that this 15 oscillations in 30 seconds. So one oscillation will be in 2 seconds. So T2 is equal to 2 seconds. So now here we put L1 equal to 4, in this is T2 is equal to 2 seconds, so this is now square of 2, and this is now 4 seconds, so this is now square of 4. So by this one, this will cancel, so this is your 4 by 4, and this L2 is equal to 1 meter. This is the answer. So thus we will get that the L2 should be 1 meter. Now we have a question from the spring pendulum. Now you are given that the fourth constant of spring is 6th question. The fourth constant of spring is 200 Newton per meter. A body of mass, body of mass 200 upon pi square kilogram attached with the spring. Attached with spring. Oscillates. Execute SHM. Find the time period. Find the time period. Now its solution. Now this t equal to 2 pi square root of m upon k. Now you are given this k equal to 200 Newton per meter and this m equal to 200 upon pi square. So much kilogram. You put these values. 2 pi square root of m is equal to 200 upon pi square. This is now your 200. This will cancel. This is now your 2 pi upon pi. Being a pi square, this pi and pi cancel. So t equal to 2 seconds. This is the answer. So these are some questions that I told you, and you may find many questions. They are the concept based questions, and nothing you have to solve the big questions because they are not asked in your this engineering exam, and that in case of NEET exam, because you know that the questions are more and time is less. So only a short question based on your understanding and that your concept, that is the questions they are based upon it. So just you have a practice and find the number of questions of very simple kind. This will make you clear the theory that you have studied so far in the simple harmonic motion. So this is the last of this chapter 14, and in the next lecture I will take the chapter number 15. So you all like, share and subscribe this video. Thank you.